The vocal tract are the set of structures that are involved in production of speech. This starts with the lungs, providing energy through respiration, through the larynx, which can modify that airflow to create sound with phonation, and into the vocal tract proper, where articulation happens. That includes the pharynx, oral cavity, and nasal cavity. We often look at the vocal tract in a mid-saggital section, where we can see articulation in the oral cavity, possibility for airflow through the nasal cavity, and the two of those coming together posteriorly in the pharynx. This image from the book likens the vocal tract to this kind of F-shaped tube that the sound of speech resonates through. So in the abstract, our vocal tract for speech consists of three tubes that are connected together abstractly in this kind of F-like shape with two branches, the pharynx leading into both the oral cavity and the nasal cavity. This tube model is important for the end results of speech acoustically, which are summarized by what's called the source filter theory. The basic idea is that we have some sort of sound source that happens by constricting expiratory airflow from the lungs. In your classic case, this occurs at the larynx with phonation, like for vowel sounds like ah, or resonant consonant sounds like But sound sources can also be created in the mouth for some of our consonant sounds, like the burst in a t, or the frication noise in a s. That sound source is modified by the vocal tract, which acts as a sound filter, and the size and shape of the configuration of the vocal tract determines how that sound gets shaped. Generally speaking, larger spaces resonate with relatively low frequencies, and smaller spaces resonate with relatively high frequencies. One place you can see this is just kind of in the overall vowels versus consonants dimension. Vowels tend to have lower frequency information in them. Ah, oo. Consonants tend to be much higher in frequency, like in our t and s. Here we have a graphical representation of the source filter theory. We have our representation of the sound source on the left, in this case in a spectrum. This is something that you will learn about in your basic speech and hearing science class. The details of that are not important here. That source spectrum gets modified by the shape of the vocal tract. In this case, a vocal tract shaped for making an E sound, for example, where the bulk of the tongue is raised upward and forward toward the teeth. That changes the resonating space in the vocal tract so that certain frequencies are highlighted and have higher peaks. Those are marked with the F1, F2, and F3 in the graph on the right. And other areas are much lower. Sound has been filtered out. So the combination of the sound source and this filtering function creates a distinctive acoustic pattern associated with this particular speech sound. I'll talk about the different source filter types kind of in the form of questions. For an O vowel type sound, or any of our resonant consonants that are not nasal, we have a sound source through phonation. If you say O yourself and put your finger or your thumb up against your larynx, you can feel that vibration there. So we have a phonation sound source. For the non-nasal sounds like our vowels and non-nasal consonants, the resonator there is going to be the oral cavity. So the combination of source and filter is a combination of phonation and the oral cavity. Our second type of source filter is a consonant type sound, like a k or a t or a s or a sh. Here, we don't have vocal fold vibration going on. We have a sound source generated by making some sort of constriction in the mouth. Where that constriction takes place depends on the sound. It's different for a k than it is for a t than it is for a p, for example. The filter resonator for that sound is the oral cavity, wherever that sound is made in the oral cavity. from that point forward to the lips is the resonating space for that sound that shapes it. So for our standard consonant type sounds, our combination of source and filter is constriction in the mouth and filter in the oral cavity. For our nasal type sounds, including the ng shown here, usually spelled ng, or a n or a m sound, we do have phonation taking place, vibration of the vocal folds, but what makes these sounds special is the fact that they're nasal sounds, and so the resonation goes through the nasal cavity rather than the oral cavity. So combination of phonation and oral cavity, phonation and nasal cavity, or constriction in the mouth and oral cavity give us our basic vowel type sounds, our nasal consonant type sounds, and our other consonant type sounds. The one combination that we don't have at all is some sort of constriction in the mouth resonating in the nasal cavity. That combination doesn't happen. Describing the vocal tract in a little bit more detail, the oral cavity is delineated by the space between the lips and the facial pillars. We sometimes make reference to the buccal cavities and the sides between the teeth and the cheeks. The pharyngeal cavity goes from the facial pillars and the velum down to the larynx. The nasal cavity goes from the nares in the front of the face to the velum. And the nasal cavities, there are left and right nasal cavities that are divided in half by a variety of bones. Here is a graphical representation of nasal, oral, and pharyngeal cavities, where I was a little bit careful to indicate that dividing line between the pharynx part of the cavity and the nasal or oral part of the cavity. Here we have a different view of the oral cavity, such that you might get on an oral inspection looking at an actual person. The front of the oral cavity is at the lips. The sides of the oral cavity are partially defined by the teeth. At the back of the oral cavity, we have the facial pillars, which lie over the palatoglossus and palatopharyngeal muscles. The top of the oral cavity is the hard palate, and the bottom of the oral cavity is the tongue. On the oral side of the hard palate, in the anterior, we have the alveolar ridge, which most people have little ripples in the skin there called rugae that are relatively sensitive to touch. It's one of the reasons why we have a lot of speech sounds there. The skin on the hard palate is divided into two pieces by a median raphe. It's a different median raphe than the one that's in the middle of the mylohyoid muscle, but it's basically the same kind of thing. There is epithelial tissue covering the hard palate. It's relatively thin in the front and gets thicker in the back. And then as you continue further posterior from the hard palate, you have the soft palate. We further subdivide the pharynx into three different pieces. The oropharynx, basically the part of the pharynx directly behind the tongue, from the facial pillars down to the laryngopharynx. The nasopharynx is that uppermost part of the pharynx above the velum, basically from where the velum is to the entry to the nasal cavity through nasal choanae. And then the laryngopharynx is the inferiormost part of the pharynx, that pharyngeal space just above and to some extent behind a little bit the larynx, from where the hyoid bone is located down to the adytus of the larynx. The nasal cavities are bordered below by the hard palate, at the front by the nares, the opening to the outside world. At the back, we go from the nasal cavities to the nasal pharynx through channels through the concha called nasal choanae. There's a central division in the nasal cavities called the nasal septum, which also includes the vomer bones and part of the ethmoid bone. The outer sides of the nasal cavity are defined by the maxillae, part of the ethmoid bone, part of the palatine bone, and part of the sphenoid bone, all things that are going to be covered in other parts of the anatomy in Chapter 6. The nasal cavities are lined by a ciliated mucous membrane to help trap particles that might be trying to enter the airway, and also to warm up the air that you're breathing in. Another big picture aspect of speech production and the source filter theory involving the vocal tract is the articulators. We have a variety of articulators that we use in speech production. That'll be covered in this chapter. One broad division we can have between them is between the mobile active articulators, the one that do the speech gestures, and the immobile or passive articulators, the locations where those speech gestures take place. So among our active articulators we have the tongue, which has several different parts to it: the tip, the blade, the dorsum or tongue body, and the tongue root at the base of the tongue. And also the epiglottis is at the base of the tongue. We have the jaw, also known as the mandible. We have the velum, also known as the soft palate. We have the lips and their connection to the cheeks that act as an articulator in some cases. And then we have the larynx and the hyoid bone that can be used in articulations for some speech sounds. For our passive articulators, we have locations like the alveolar ridge at the front of the oral cavity, the hard palate, the superior middle part of the oral cavity, the teeth, also at the front of the oral cavity, the posterior pharyngeal wall at the back of the pharynx. Here is an MRI image of the vocal tract showing some of those different active and passive articulators in a mid-saggital scan of an actual human body. So this isn't some sort of drawing or approximation. This is a scan of an actual person showing the different sections of the tongue, location of the alveolar ridge, hard and soft palates, uvula hanging down at the end of the soft palate, pharyngeal region in the back near the tongue root and epiglottis, and leading down through the larynx to the rest of the respiratory cavity.